Exercise 1.3, Problem 4, Division 1, Discussion. Verify A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. We just need to verify this cardinality law for A union B union C for set A equal to 4, 5, 6, set B equal to 5, 6, 7, 8, set C equal to 6, 7, 8, 9. Are you able to recognize the difference between this problem and the previous problem? In the previous problem, they had given us directly the cardinal value of set A, set B, set C, etc., etc. Here, they have straight away given these three sets A, B, and C, which means we'll have to find n of A, n of B, n of C. Find A intersection B first, then find n of A intersection B. I have to repeat the same steps for all these. Okay? So that is a key here. So, given set A, set B, set C, we need to prove that this n of A union B union C is equal to this. And there is no formula or hint. So the step 1 is we need to find A intersection B, B intersection C, A intersection C, A intersection B intersection C, and A union B union C. All the unknowns, right? So we need to calculate this, we need to find this, find this, find this, find this, and then in the next step, find the cardinal values of all these sets. So step 2, find the cardinal values of all these sets. Step 3, substitute all these values in this equation and calculate your left hand side and calculate your right hand side independently and check whether those two are equal. Okay, that's all it is. In the previous case, they gave us all these values. We just substituted and checked it out. Here, they given us the sets itself. So from which you'll have to find all these additional sets like A intersection B, B intersection C, etc. And after that, we'll have to find the cardinal values of all these sets and substitute them in this equation. Calculate your LHS and calculate your RHS and see whether they are equal. Okay, so what I suggest is pause the video here and try to go through this, try to do this problem on your own, and on completion, come back and check your working against our solution. Okay, the solution. So what's the first step? N of A. So that is 3. How many elements are there? 3. N of B, 3 elements. Oh, sorry, 4 elements. N of C, 4 elements. Find A intersection B. What is the common element between 4, 5, 6? So 5 and 6 is a common. So n of A intersection B is 2. Next, we need to calculate B intersection C. Common between B and C. So 6, 7, 8 is common, right? B intersection C is 6, 7, 8 and n of B intersection C is 3. Next, we'll have to calculate the difference in common between A and C. A intersection C. So if you see, 6 is the only common element. A intersection C is 6. And n of A intersection C is 1. Now, you have to find common between A, B and C. So, which is the smallest set? We'll take A and check out element by element. Is 4 present here? No, it's not there. 5, yes, it is present here, but it is not present here. 6 is present here, and present here. So, which means A intersection B intersection C is 6. And the best method is to start from the smallest set. Okay? Because then the number of steps you have to do is the lowest. So, n of A intersection B intersection C is 6. And, A intersection B intersection C is 6. And n of A intersection B intersection C is 1. Next, you have to find n of A union, you have to find A union B union C. Combine all these sets 4, 5, 6, 7, 8, 9. Right? Because 5, 6 is repetitive and 6, 7, 8 is repetitive here. So, we will drop it off. Okay. 4, 5, 6, 7, 8, 9. And how many elements are there? 1, 2, 3, 4, 5, 6. So, n of A union B union C is 6. Now, you substitute all these things. N of A union B union C is 6, which is your LHS. Now, you substitute all these values in this equation and calculate the right side. Okay. Okay, so or both sides we can do. So n of A union B, substitute all these values. So this is 6. N of A is 3. N of B is 4. N of C is 4. right? And n of A intersection B is 2, n of B intersection C is 3, n of A intersection C is 1, n of A intersection B intersection C is 1. So substitute all these values. LHS is 6. Now check your right hand side. 4 plus 3 7, 7 plus 4 is 11. 11, okay, 11 plus 1 is 12. So it is 12, right? Then this is minus 2 minus 3 minus 5 minus 6. So 12 minus 6 is 6. So you will get 6 equal to 6, which is true. Therefore, n of A union B union C is equal to all these things. Okay? So that's the only difference here. That is, instead of giving you n of A, n of B, n of C and all these cardinal values, they have given you these sets itself. A, B, C, and they are asking us to find A. You have to find A intersection B, B intersection C, etc., etc. Then you have to find the cardinal values of all these things and then apply the formula. So that's the difference in this problem. Okay. So I hope I made it clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.